Let's have another example. And the measuring land, map making, or decorative design are are couple of it, or some of its some of the usual applications of elementary geometry, and there are another applications which I talk about them later. The theorems and examples I talk about should not necessarily came from measuring land or surveying or decorative design. Okay, so let's prove another theorem. It says in every isosceles triangle like this, A, B, and C, take a point on BC. These two are equal. The theorem says that the distance of this from AC plus the distance of it from AB equals to this altitude. And I mentioned before that distance of a point from a line is the length of the perpendicular to that line. Okay, but again here we got let's H, and this is H1. So the theorem says that pH plus pH1 equals to Bn. This is N, the altitude. Again here we got the sum, so we should make a line segment which length be this. So how should we make it? Here we got pH and we extend it as pH1, and let's call it N. Okay, and join these two. Now the problem is to show that NH, which is equal to the sum, equals to Bn. Now, here we got two lines which making equal angles with AC. Then these two should be parallel. Okay, now so far you know that these two lines are parallel, and BN HN got two right angles. Now if we prove that this is a rectangle, then these two should be equal to each other, and we okay, let's prove that this is a rectangle, and in order that we should prove that this angle or this or n is a right angle. Okay, now we made NP to be equal to PH1 at first, remember, and in triangle BPN, this little here, and we show that like this, and triangle H1 PB, this above. First we got two equal sides, this and this. Okay, and we got a common side, this, and okay, here we want to prove that this is a right angle, and we want to prove it using, we want to see if the two triangles here be congruent, then this should be equal, this angle should be equal to this angle, which is 90 degrees. And okay, now so far we know that. Now let me draw it here. So far we know that this is equal to this, and this is the common side, and if this angle be equal to this, then we are done. Okay, and we want to prove it, but this angle which is here, this P1 say, is what? P1 is 90 degrees minus B, because here we got a right triangle and sum of the angles should be 180, so the sum of the rest should be 90 degrees, so this should be 90 minus B. Okay, and here we got another right triangle, and let's call it P2, so P2 should be 90 minus C, but since this is a an isosceles triangle, then C equals to B, so P2 should be 90 degrees minus B also, but P2 equals to this P3 say, or this angle here, this is equals to this, because these are two intersecting lines and these two angles are equal. Then P3, which is this, equals to P1, and the two triangles, this and this, are congruent, and this equals to this, which is 90 degrees, and this is a rectangle, So NH equals to En. Let's have another theorem. Let's prove another theorem. Here we got an equilateral triangle. Now let's make it big. The theorem says that for every point inside of this, the sum of the perpendiculars or the distances from the sides equals to the altitude of this triangle, and the altitudes to every sides are equal because this is an equilateral triangle. So here, again here we got sum, we got a sum. So one way is to construct or make the line segment which length would be equal to the sum. But in this particular example, we could do better. How? Here, if we draw the line parallel to this side, so this is equal to this. This is equal to this. Again, here we got another equilateral triangle. As the angles are equal, the lengths should be equal also. Now, I didn't prove it before, but this is a theorem. So here, and an equilateral triangle is a special case of an isosceles triangle. So according to the previous theorem, the sum of these two should be equal to the altitude. But since this is an equilateral one, this altitude equals to this altitude also. So the sum of these two distances or perpendiculars equals to this altitude plus this, and from here make another perpendicular to this. So then these two lines are parallel, then this is 90 degree, this is 90 degree also. So here we got a rectangle, which means that this is equal to this. So the sum of these three would be equal to this plus this, which is the altitude to this length, to this side, which is equal to altitude to the other sides. Okay.